Hello, and welcome to Pi's Periodic Principles. Today, I will be teaching a lesson on the arrangement of electrons in an atom, also known as electron configuration. There will be three different scientists we will be learning about today, Pauly, Aufbau, and Hund, who all discovered different things about electrons and made rules about them. The first rule shows the order in which electrons occupy orbitals. According to the Aufbau principle, an electron occupies the lowest energy orbital that can receive it. This picture shows the atomic orbitals in order of increasing energy. The orbital with the lowest energy is the 1s orbital. In a ground state hydrogen atom, the electron is in this orbital. The 2s orbital is the next highest in energy, then the 2p orbitals. Beginning with the third main energy level, n equals 3, the energies of the sublevels in different main energy levels begin to overlap. Note in the figure, for example, that the 4s sublevel is lower in energy than the 3d sublevel. Therefore, the 4s orbital is filled before any electrons enter the 3d orbitals. Less energy is required for two electrons to pair up in the 4s orbital than for a single electron to occupy the 3d orbital. The second rule reflects the importance of the spin quantum number. According to the Pauli exclusion principle, no two electrons in the same atom can have the same set of four quantum numbers. The principle, angular momentum, and magnetic quantum numbers specify the energy, shape, and orientation of an orbital. The two values of the spin quantum number allow two electrons of opposite spins to occupy the same orbital. The third rule requires placing as many unpaired electrons as possible in separate orbitals in the same sublevel. In this way, electron-electron repulsion is minimized so that electron arrangements have the lowest energy possible. According to Hund's rule, or the empty bus seat rule, orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and all electrons in singly occupied orbitals must have the same spin. Applying this rule shows, for example, that one electron will enter each of the three p orbitals in main energy level before a second electron enters any of them.
Now it's time for you to practice what you've learned today on your own. Here are some practice problems. Draw your own orbital diagram for lithium. Refer to this periodic table that gives you the names of the groups and shows you how many blanks go in each group as reference if necessary. Take a few minutes to work this problem on your own. This is the diagram you should have come up with as your answer. See how Hund's empty bus seat rule is obviously used in the S2 blank as it has no partnering arrow. See how Pauly's rule is obviously used in the 1s blank as the two arrows are going in opposite directions due to their opposite spins. Moving on, try to draw the orbital diagram for carbon. This is the diagram you should have gotten for carbon. Everybody got that? Great. Now let's move on to some trickier ones to test your ultimate understanding. Try to draw the orbital diagram for aluminum, for silicon, for phosphorus, and for sulfur. Everybody take a few minutes to do this on your own. These are the answers you should have come up with for aluminum, silicon, phosphorus, and sulfur. Everybody got those? Great! My job is done. I hope you learned everything you need to know about Pauly, Aufbau, and Hund today. Any questions? No? Great! I'm glad I could help you, and thanks for listening to Pi's Periodic Principles.